Take 3. So, every row, column, box, 1 to 9 must be placed without repetition now. Box 1 only has 5 candidates left, but let's start looking at the rows. I have 3 1s, I have 2 2s. I'm missing... There's box 1, there's box 3. Box 2 must go there, but there's only 2 spaces left for a 2. I don't have enough 4s. I do have enough 5s. That's a 5, and that's a 5. The 5 in column 1 must go in the bottom row, and there's in fact only 1 spot. That's a 5. I don't have enough 6s. I have 2 8s and 2 9s. The 9 in the middle must go in one of these places. In column 3, because 1 and 2 are already taken. And the 8 must go in one of 3 places in box 3, except this 8 rules that one out, this 8 rules that one out, so that's an 8. And that's a write-in. These 4 digits here are from a set consisting of 4, 6, 7, and 9. But it can't be 4 2 ways, and it can't be 9 because it's already in the box. So that's a 6 or 7. This one is also a 6 or 7. That means these 2 cells are a 4 9 pair. Is there anything useful I can do here? 1 2 4 5 8 9 says this can't be, this is 3 6 or 7, but it can't be 3. This being 3 6 or 7, except it's not 6, it's 3 or 7. This one, annoyingly, can be any of 3 6 or 7. Let's see, if that one's a 6 7 pair, then by definition that's a write-in 3. These 3 cells are from the set of 2, 4, and 7. No, I don't want to do that just yet. This can't be 4. This can be 2 or 7. This one can't be 7, so it's 2 or 4. This one can't be 2, but it could be 4 or 7. Is there anything else I can do that's easy? Not really, because almost everything else has 4 or 5 boxes still left. I don't know that I can really write candidates. Maybe I'll try row 5 next. This has 1 2 5 8 9 in it, so it's missing 3 4 6 7. Can't be 3 or 4. That one can't be 7, but it could be any of the other digits, I think. This one can't be 3 or 6, so this is 4 or 7. Where's the other 4 7 pair? I'm not getting it. Let's see. Row number 6 here. I have 1 3 4 5 already in. So this is... These are from 2 6 7 and 9, but it can't be 7 or 9, so this is 2 or 6. And it can't be 2, so that one must be 6. These three are now 2, 7, and 9, but I can't eliminate any of these. This is 2, 7, and 9, as is that. Let's see, row 8 only has 4 left in it. Let's try that. I need 2, 4, 7, and 9. But this one can't be 9 or 7. So this is 2 or 4. This is 2, 4, 7, and 9. But it can't be 2. This is 4, 7, and 9. This one can't be 2. It could be 4, 7, or 9. And this one can't be 2 either. So it too is 4, 7, or 9. That's annoying. Except if these three must be 4, 7, and 9, then that one by definition must be a 2. Because it can't be any of the other digits. I can only have 1, 4, and 1, 7 in this row. And if I've already eliminated or stipulated 4 and 7 must go in these 3 spots, this one cannot be a 4. And therefore that's a write-in 2. Now that does prove interesting for column 5 maybe. This one can't be 6 or 4, so that one must be 3. That's now 2 or 4, but it can't be 2, so that's 4. This one is the only digit that's missing. That's a 1. Let's see, that's a 6 or 7. That's a 6 or 7. No, 1, 2, 3, 4, 5, 6, 8, 9. Okay, this is 7 or 9. Actually. This is 6 or 7. But it can't be 6. So this cell must be 7. That cell, therefore, must be 9, and that takes care of column 4, 5, 6, and box 5. Just about. Because column 5 is done. As far as column 4, I'm now missing 2, 6, and 8. Well, this one can't be 6. It must be 2 or 8. This one can't be 8, so this is 2 or 6. And I hope I didn't mark something wrong, because I've now got... Well, maybe I did. I can only have 1, 2 here. And if that's a 2, 8, and that's a 2, 6, this one can't be 2, because one of these cells must be a 2, and therefore I think that's a 7. Whoops. Well, that's a problem. No, it couldn't have been a 7 anyway, because there was already a 7 there. So, this is 6 or 8, this is 6 or 8, except by row logic, that's an 8, that's a 6. There's already a 6 and 8 in the respective rows that I was trying to place the other digit. I'm now left with a 4, 7, 9 here, which I can't really do anything with, annoyingly. Box 8, I still needed to place a 3, and I still need to place a 9. Neither of which I can eliminate. This is 1 or 2, already there. 3 and 4 are missing. 5 and 6 are already spoken for, so 4 and 7. This is 3, 4, 7, and 9, but it can't be 7. This is 3, 4, 7, and 9, but it can't be 3, 4, or 9, so this must be 7. This one, that's now a 3, 4, 9 triple, which is not 9 or 3, so that must be 4. Which makes this now a 3, 9 pair, except this can't be 3, so that must be 9, and therefore that's a 3. Let's see, I have 2 3s in my bottom 3 rows, therefore 3 in actually box 9 must go in one of these cells, but it can't go in the central top left, so that one's down to 2 places. Let's see, this one is down to only 2 possibilities. Box 7 down on the lower left. This must be a 2 or 5. This must be a 2 or a 5. All the other digits are accounted for, but this can't be 5. So that must be 2. That must be 5. Let's see, I'm now down to 4 candidates in this box, and that should make my life a lot easier. I'm missing 1, 3, 4. Whoops. I'm missing 1, 3, 4, 9 here. But it can't be 1. This is from 1, 3, 4, 9. But it can't be 1. It could be any of the others. This is from 1, 3, 4, 9, but it's not 3. So this is 1, 4, 9. This is 1, 3, 4, 9. That's not 1. So this can be 3, 4, 9. Well, if that's a 3, 4, 9, and that's a 3, 4, 9, and that's a 3, 4, 9, then this one, by definition, can't be 4 or 9, because then I have too many 4s or too many 9s. I think that must be 1. Going back and cleaning up some of my earlier boxes, this one, well, we think I ruled that to be a 4 or a 7, but that's a 7, so that's a 4. This one now has to be a 6. Let's see. This cell and this one form a pair, but of what, I don't know. I mean, this one could be 2 or 9, but I think that's... If I said this one was 2, 7, or 9, but it can't be 2 and it can't be 9, that must be 7. So it can't be 7 or 9. So that must be 2, which forces that to be a 3. That takes care of box 4 and column 2. This box is still a 6 or a 7, I think. But it can't be a 7. It must be a 6. That must be 7. Let's see. 4 or 9, I still haven't eliminated from here. This one I still haven't done anything either. This one is now 4 or 6, right? This here, because of the box, I have 1, 2, 3, 5, 6, 7, 8. This is 4 or 9. And that's 4 and 9. That's a 4-9 pair that I can't resolve just yet. Let's see. There's a 7 there and a 7 there. A 7 must be in one of these places, but I already determined that. Okay, this is 3, 4, 9 here. I don't know what's going on there. I don't know that I can eliminate these yet. Okay, these 3 cells must be from 2, 6, and 7. But this can't be 6. So this is 2 or 7. This one can't be 2 or 6. It must be 7. And now this one being 2, 6, or 7, I've ruled out both 7 and 2. It must be 6. And therefore that's a 2. This is the only cell that's left. It's a 9, by definition, which means that's not 9. And that's not 9, so that's now a 3, 4 pair here, which places this cell, that must be a 9. And therefore that must be 4. This cannot be 4. So I'm down to a 7 or 9. That's a 3, 4 pair. That's a 7, 9 pair. This is a 4, 7. Oh, that's now been resolved. That's a 7. Let's see, that can't be 6. So that's a 3, 7. That's a 3, 7. That's a 4, 9. That's a 4, 9. If these are 3 and 7, then this one must be 6. Plus, it's the only thing left in that column. So I'm now down to just my rightmost 3, and theoretically they should all be right ends, except I've got 3 4s and a 7 9 and a 3 7 and a 4 9. Okay, so what's left here? 3 must be in one of 2 places in box 3 because of that 3 and that 3, but I can't rule either of them out by this column. This one is 4 and 9, except it can't be 9, so that must be 4, which makes that 9. This is now 3 or 7. This is now 3 or 4, except this can't be 4, so that must be 3, which makes that 7. That 3. I'm now down to 5 boxes left. This one is only missing 1 digit in its row, so everything is a right in at this point. 5, 6, 7, 8. Okay, that must be 9. That makes that 7, and this one, because it can't be a 3, must be 4.